Hello. So, hi, is the voice clear from my side, or do you hear noises? All right. So recording is started. Now we can start the session. All right. So far we have been through the general description of big data. Then we talked about HDFS. Then we talked about the MapReduce. And MapReduce we went extensively. We discussed the streaming. We discussed how to do it in Java, and we also went through quickly how to convert most of the problem into MapReduce. All right, and we also talked about partitioner, combiner, input splits, and whatever things are required for MapReduce, we discussed. All right. Now, the next topic which we are going to discuss is pig and piglatin. All right. So, do we have any follow-up questions before we move forward? No questions. All right. All right. So, moving ahead. So, a brief description of pig is it's an engine for executing data flows in parallel. All right. So, basically, it whenever you have to convert one form of data into another, you can use pig Latin, specifically in the cases where the data is really big. All right. And pig provides you something called pig Latin. And pig Latin contains things like join, order by, filter by, group by, whatever was there in SQL. And it runs on Hadoop and it makes use of both HDFS and MapReduce. Okay. So Pig essentially is an engine that converts Pig Latin. Pig Latin is something, a language like SQL. That's what we are going to discuss extensively. So Pig converts Pig Latin into MapReduce and executes in on Hadoop utilizing HDFS and MapReduce. All right. So this is how a typical Pig Latin program looks like. This is a comment. This is a comment. So this line says input equals to load big.txt as a particular column name. Okay. So it will basically load that big.txt as a bunch of as a single column data set. All right. So there's no full form of pig. Pig means pig. Okay. So pig is more like SQL, which is a sort of an interpreted language. Okay. So this is how it looks like. If you don't understand, never mind. It is you are not supposed to understand it right away. It's just a quick overview that giving you an idea about what are we getting into. So this line shows that load a file as line, meaning single column, and then we have this where we for each input we generate the we generate this thing. All right. Then there is a for each where we are iterating over the input and then transforming the data into something else, basically breaking the lines into word and then grouping those words by word itself and then counting it. All right, and that's it. So this is how it looks like. The one which is in the bold is Pig Latin, and rest of it is comments. All right. So essentially, Pig Latin is a data flow language, and it allows you to describe how data flows, how it should be read. Yeah. So here it shows you tokenize by default takes the space. All right. By default takes the space and tab and breaks down into that. Okay. No worries if you don't understand it right now. So in Pig Latin, you can describe how does your data flow. Here, big.txt was loaded into input, then whatever was the result of this for each was loaded into words, and then whatever was the result of group went into grpd, and then whatever was the result of iterating over this for each went into this, and then we basically printed the counts. Okay. So basically, from the top to bottom, we have been, transforming one data into another, and that's what it is about. So Pig Latin allows you, Pig Latin allows you to describe how does your data flow, how should it be read and processed. Yeah, it is somewhat like R, but it does not have if and normal for loops. It has for each loop. You can create really complex workflows. All right. The only big difference is everything in Pig Latin gets converted into MapReduce. Everything, whatever you write in Pig Latin, gets converted into MapReduce. All right. Now, why do we need such a language? Why didn't we just utilize MapReduce and just used it instead of creating a new language? We should have just kept on using MapReduce. Okay. So the reason behind creating a new language is, though MapReduce is really flexible, but it is cumbersome. It takes time to form a logic. It takes time for compiling, transferring, and then executing. And Java or any other programming language, it takes more amount of effort as compared to a very data oriented language. Okay. So MapReduce, so Pig Latin basically provides you join, filter, group by, order by union, etc., etc., while MapReduce only provide you kind of a group by and order by indirectly. So so and joins are really hard. If you remember our fourth problem, where the democracy problem, where people are voting for each other, their joining the two data sets was too much of a headache, right? So i- after a point of time, after a point of time, writing code in MapReduce becomes really repetitive. Okay. So if you are joining the two things and all of that becomes really repetitive. All right. So MapReduce is not something which an analyst can use, but Pig Latin is something very easy to understand and has lot of inbuilt libraries for data oriented work. So your code is opaque to MapReduce, meaning MapReduce doesn't care much about how you are dealing with the data. But in case of Piglatin, since you describe the data, it matters in case you miss out a column. Just like in SQL, if you are trying to access a column in a table which does not exist, it gives you an error immediately. Okay, it can give you the error even at the compile time. Okay, so the same word count problem, same word count problem which took us 170 line to write in MapReduce will take around 9 lines here. Okay, the only thing that wins, the only positive part about MapReduce is you have more control over the overall flow. While Piglatin has its limitations, but those can be overcome by writing various kinds of UDF. UDF stands for user defined functions. All right. Now, okay. So why didn't we use SQL instead of just inventing a new Piglatin? Okay. So all of you must be agreeing that MapReduce was cumbersome. MapReduce required a lot of developer kind of a mindset rather than somebody who wants to manipulate data. Okay, so that is very clear to all of us. But why did we need Pig Latin like a new language? Why couldn't we just live with SQL? Okay, so Tarak's question is more control, as in more control on overall things. So you in Pig Latin you can only do those things which are provided by Pig, whatever functions, whatever libraries are provided to you. And as I told you that if and for loops are not there, do while loops are not there. So 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 basically in Pig Latin you cannot do everything. Just like in SQL you cannot do everything. Okay. Therefore it's not advisable. Therefore it's not advisable to do things in Pig Latin which are very customized. Okay. So that's what I meant by the control. So you will understand this, what is better and what is not, as we go through Pig Latin. Okay. So whenever you have to do something where which is not usual for Pig Latin, okay, and for which writing a UDF is too much of a hassle, you go for MapReduce. For example, if you are writing a new kind of algorithm, or if you're trying to build a new kind of way to interpret data, and totally new, for example, you are writing a clustering algorithm. So for those kind of things, MapReduce is a good idea. All right. Now, so Nitika's question is, how can we decide? So the thumb rule to do is, if you can do something in Pig Latin, do it in Pig Latin. Otherwise, try to create UDF. And then if creation of UDF is not also fulfilling your requirement, then you go for MapReduce. All right? Make sense to you? So decision between Pig Latin and MapReduce will be very easy. You will start with Pig Latin, and in case your requirement is really complex and cannot be done in Pig Latin, you will move some parts to MapReduce. Okay, but when we talk about Pig Latin versus SQL, it takes a little bit while to basically justify why did we need a new kind of a script? So the biggest reason is that in case of Pig Latin, Pig Latin has been designed for big data bottom up. So big data is a lot about optimizations. Everywhere you will be doing a lot of optimizations, and those kind of optimizations are really hard to achieve in SQL. And the language does not allow you to have unstructured data or semi-structured data, while Pig Latin allows you to have semi-structured data. Okay. So yes, Tarak, yes, we can code few parts in Pig Latin and rest in MapReduce, correct. And the way most of the project happen is you generally utilize multiple level of tools, multiple kinds of tools to achieve something. So in Pig Latin, you basically describe how to exactly process the data, while in SQL, you describe what you need. All right. And in SQL, your intention is to create a single query that gets executed and gives you the result that leads to the very complicated queries. While in case of Pig Latin, you can do you basically write a sequence of instructions which give you the result. So construct wise Pig Latin is far easier than SQL and far more easier to understand as well. And Pig Latin has been designed bottom up for big data and Hadoop, while SQL has been designed for relational databases. Okay. Now Pig Latin targets multiple data operations and parallel processing. Okay. And when you try to do multiple data operations in SQL, the query keeps on going complex. And Pig Latin can be used when schema is known, incomplete, or inconsistent. Okay. If you're, say, you are dealing with CSV file, if you want to load CSV file into the database, you will have to describe each and every column before loading that CSV file, while in case of Pig, you don't have to describe each and every column. It will assume a lot of things, and whenever required, you can specify the data type. You will see when we talk about it. Okay. So, all right. So basically, it's a long series of data operations, and if you remember, if you have tried to code an SQL, you try to do a multiple join over joins to get the results. While in case of Pig, you do a multiple operation, somewhat like creating views. All right. So this difference will get clear to you when you get to know Pig Latin. Right, the more you will explore it, the better you will be able to differentiate by yourself, because in theory these differences do not make much of a sense. So if we finish Pig Latin and then we come back to this slide, then it will make more sense to all of us. Okay. So there are many use cases for Pig. Pig is basically used for transforming data from one form to another. It's not for real-time applications. It is good for transformation of one data into another, and it's generally used for ETL, which is extract, transform, and load. And second, and then research on the data, and then iterative processing or batch processing. So there are actually many use cases for pig. Wherever you can use SQL, you can use pig. Transformation means, yeah, transformation means, transformation means, say you have got one database table, you want to change one column values to another something, or you would just want to pick up few columns out of it, or you want to group the data on this table, or you may want to pick up only certain rows out of the data. So those are the examples of the transformation. Okay, a general philosophy which pig will adhere to first is pig eats anything, whether data is relational, nested, or unstructured. Pig eats anything. Pig handles all kind of data. Pig lives everywhere, or pig lives anywhere. So whether you are dealing with parallel processing, okay, so it's not designed for only Hadoop. It is designed for any parallel processing or distributed application. Pigs are domestic animals, meaning pig is customizable and controllable. You can create UDF and custom functions using Java and Python. You can create custom load and store methods, just like input split customizations. In the similar fashion, you can have custom load and store methods. Whether your data is in JSON or whether your data is in XML, you can load that data using pig. Pigfly, pig has been designed for performance. So I have just now explained controllable, right, Nitika? So controllable means you can customize pig. You can control pig in case you don't like some function, you can create your own function. All right. So the general way to install pig is only the client library. Pig does not have any server side. It's just a library which internally converts the your instructions into into MapReduce execution jar. Okay. So a quick way to install pig is you download the pig release, extract it, and then you start using it. As simple as that. You just need Java underscore home. That's all. Now, even if you do not have Hadoop installed, you can run pig Latin script by saying pig minus x, a pig minus x local, which will basically run in sort of an emulation mode, and will try to pretend as if it's running MapReduce. So it's good for testing. And and if you have Hadoop installed, all you need to do is the location like etc Hadoop where all Hadoop configs are stored. You just mention pig underscore class path, and that's it. And rest pig will take care of. Okay, it will figure out where's name node, where's data node, and how to execute this or how to execute that. Everything will be taken care by pig. All right. So a quicker way, but you don't have to do any of that because we have already installed pig on our cloud labs. Okay. So you can simply SSH to one of the nodes. So today I'm going to SSH to some other node, student at hadoop1.nobigdata.com. All right. Now here we can execute run pig. and we are in the command prompt. All right. The alternative could be you can use Hadoop 1 8000, and from there you can execute your SQL queries, big Latin queries. All right. Okay. So these are the few examples of queries, big queries. All right. You can also write your own one. You can say new script and start. Other than that, I generally prefer the command line because here I get the results quicker as compared to the web one. Okay. Okay. So for today, we have copied the data into a folder called data onto HDFS. So we can say, and yeah, this is the location where all the data for today's session is available in HDFS. Okay, user, student, and data folder. Okay, so there is something called pig minus x local. This you can actually run on your local machine. Without for this, you don't need Hadoop. This is good if you are trying to just run few test cases locally. That's all. But it's not good for anything else. Okay. Now, with respect to the command line argument, other than pig minus x local, you can say pig my script dot whatever is your script name. So this will execute your script. And what is a pig script? Pig script is nothing but all the commands, all the whole sequence of command written down in a file. That's all. And if you have just one single query to execute, you can say things like pig minus e and then give the command name. Here I'm giving the ls command. Ls is a valid command in pig, which basically gives the list of files at HDFS. Okay. So this is the pig. When you type pig and the command prompt is called grunt, this is where you will be typing all the commands. So Vikas, there is no need of any extension. This whole culture of having extension is something which comes from uh, comes from the Windows side. Okay, so the way Unix identifies how to execute a particular script is from the first line. Okay, so from the first line of any, say for example in this my command.sh, what we gave in the previous session, the first line is what describes the program name with which this rest of the scripts need to be executed. All right. So in Unix, it's the first line that identifies how to execute a particular program. Okay. So you will have to write in your pig script. If you write slash in the beginning of line hash exclamation mark user pig, and then you just make it executable. It will internally, if you try to execute this particular script, it will internally call pig to execute that script. All right. Now, at the pig prompt, at the pig prompt, you can type normal commands, whatever you had typed with Hadoop FS. Okay, such as ls, such as copy from local, right? Copy from local, L capital. Okay, so here this is the command, copy from local, my file, and some data folder. Okay, so it copies the data there that way. Also, from the inside of the command prompt itself, you can load a script or execute a script. So Vikas's question is, will I be able to do ML operations with Pig like decision trees, recommendation, etc. So by default, Pig does not provide those libraries. But if you have Java functions doing the same thing, you can make the calls to them. By default, Pig doesn't have all those libraries. All right. The general basic construction of Pig is the language construction. Each processing step results in a new data set, except for the cases where you want to print the output to the screen or you want to save the data to some file. Except for those two, rest of the steps result in a new set. New set is also called a relation, exactly like the tuple algebra. If you have read about tuple algebra when you were studying databases, each table or each set is called a relation. Okay. Okay, so most of the pig latin is case insensitive, except for the function or udf functions, which are case sensitive. You have multi-line commands like c and single line commands like sql. All right, and this table is basically, let's have our first script up and running before going into further. Yeah, so this is the multi-line commands and this is the single line command. Okay, Nitika, so am I breaking, is my voice breaking? Okay. Okay, I don't get it which one you're asking me. So case sensitive, what does it, do you mean case sensitive, do you mean each which one are you asking? All right, so yeah, so let's go ahead and yeah, I don't get it which last question are we referring here. Do you mean the Goyal's question? Yeah, you don't have those algorithm, those libraries here. But if you have your Java programs, you can load them and use them here in Pig. All right. All right. So let's have a look at what we are trying to achieve. Imagine that we have stocks. First column represents the stock exchange name. Second is the ticker, or second is, you can say, the what do you call, stock name, and then the date, and then we have the price. Okay, now what we want to do is we want to compute average value of each of this stock ticker. Okay, for CPO, average value of these, for CCS average value of these, and CIF average value of these. Okay, if we were in we had to do it in MapReduce, we will make this as the key and this as the value, and by default all these values will be grouped together, and in the reducer we will just compute the average. All right, so here is the pig script. We loaded the data, then we just printed it. I'll show you step by step. So this one is how you load the data. So let's have a look at this file first. Okay, so all right, so from here also you can see ls minus this ls, and then this, it shows you that there is a file in HDFS which has a replication factor of 3, and this is the size of the file. Okay, we can say cat and then the file name. So it quickly uh, displays us the interesting. So cat displays the file, what is there inside the file, and all these commands cat, ls, and everything works from inside pig also. Okay, so this is what our data looks like. All right, so let's take one step at a time. Let's load this file. So this file, this HDFS file is loaded into divs, which means these divs will contain these columns: name, ticker, date, and value as 4 columns, and we have given the names to each column. Okay, so loads the data into a data set. You can define these things. We will go into the detail of load again, right? And to have a quick look, let's see what's going on here. If you say dump divs, okay, you can see what's inside divs. Okay, so you can see that whenever we are saying something, whenever we say dump, it's actually executing the MapReduce for us. All right, so it has dumped the data. Now here you can say this. Also, you can check quickly what is the definition of divs is. Divs is just another variable we have created. Okay, or you say describe divs. So it says that these are the columns in div. Okay, so we loaded a file as into a data set. Okay, and then we dumped, and after that let's group it. Group divs by a column called ticker. We define the second column as ticker, and once we have grouped, we can say compute the average by iterating over the data set, and afterwards we can store the information into this file. Okay, the directory, this particular directory is already existing, so we can say 2 May, not 2 May, 18 April. This is getting executed internally on MapReduce. So it's internally doing Hadoop jar and sending its jar for the execution. Okay, now we have stored this file. Not on local node. We have this hands over just like it's executing on Hadoop jar, and it will be sending to the Hadoop. Okay, So let me have a look at what's going on at Ambile. So Pig automatically did the writing of maps and reduces for you. So instead of you writing the Java programs, it did for you. Correct. It internally executed. All right. So our Hadoop 4 is fairly free. So can we try to use Hadoop 4? All right. Now here, so this for each loop is not like your for loop. Okay. It's more like saying go through the data set and convert this. That's all. Go through the data set record by record. It's like saying iterator. It can only iterate over the data. Normal for loop can take any variable and increment it. Here it can only go through the input data whatever you're giving and do these small things. Okay. Okay, Tarak. So basically, the for each is not really our for loop. It's more like go through the data and pick up these columns or transform these columns. It's more like select. Okay. Yeah. So it's more like select or projections. If you have heard about projections, basically when you say select a comma square root of b from my table, okay, that's the kind of for each does. Okay. Okay, and this will basically store the result into a file, and then you can see what's there in the file. Yeah. So it's basically trying to store that data into that file, and it's running these maps and reduces, and you should always have a close look at what's going on. So you can see that it also gave you a URL to track the map reduce job. So when we say group by for each and then we try to store, so the moment we launch store, then it executes all those queries which are resulting in this particular data set. Okay, you can see that there are total number of one maps and reduces, and this is what it is doing. Okay, so it has succeeded. And now we can have a look at the file. We can say cat, and where did we store it? This is the location where we stored it. Okay. Now we can say cat and the file name. And this is basically a folder, by the way. It is going to store it in a folder. So you can see the part file, which means there was only single part, and hence there was only one reducer. Okay. So we can say cat and then part and star. Alright. Part minus r 0, 0, 0, 0, 0. So you can see that it has computed the average for you. Alright. So again, let me just go through. The first line basically loaded the data. Second line grouped the data. Third line just selected few columns and computed average. And then uh, sixth line stored the data into this folder, and then this one printed what was there in the file. Okay. So this is basically equal to this. Okay. All right. So this was like a very quick overview of how would a pig script look like. This is a very quick overview of how will the pig script look like. Now next is the data types. What did dump do? Dump basically printed what was there in the in particular data set. It did not do anything per se. It's just for the debugging purposes. All right. So now let's go into one step at a time in a traditional manner. So the general way of learning a new language is quickly try to see how to do a hello world. Then 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 do the step by step process. Learn each and every construct at a time. Okay. So let's go through each step at a time. So pig also contains data types, but you don't have to define the data types all the time like SQL. So there are two kinds of data types. One is scalar, other is complex. Scalar is basically just like in Java, you have int, which is integer, long, which is a big integer, and float, which is a decimal number. Double is a very big decimal number. Character array is string. Byte array is a binary data. Alright, that's the basic data types in pig. Now there are complex data types. Complex data types such as map, tuple, and bag. What does it mean by map? Map is like a key and the value. So in each of the field, you can store a map. Just like you are stored byte array or string, similar way you can store a map. A map is a collection of key value pairs. Okay, and the way the data is formatted by pig is key and values are separated by hash, and all of this collection is enclosed in square brackets. Okay, so that's a map. So you can define a complex map. So in a data set, one column can be of the map type containing this kind of a complex structure. Second is, and the name can be a character array while the value can be another complex type. It can value can be further another map, or it could be a very simple scalar, maybe the integer, string, or whatever. So, but name can only be a char array, which means name can only be string. The second complex type is tuple. Tuple is a fixed length ordered collection. Okay. What does it mean by? The way you can think of tuple is a single row of the database table. A single row of the database table is called a tuple. All right. So, and a tuple is made up of fields and their values. You can, yeah, and either you can refer each of the column by their column names, or you can refer each of the column values by indexing starting with 0. Okay. So, for example, Bob 55 12.3, these are the three values of a row. They can also have the name, say name is Bob and age is 55, and total number of sales is 12.3. But or you can refer to each of these value like array and then 0, or array 1, or array 2, and so on. Okay. So you can access these values either using index or using a name. So that's a tuple. Bag is an unordered collection of a tuple. The easiest way to think of bag is essentially a data set. Bag is equivalent of a table in relational databases. Bag is a table, and what is a table? It's an unordered collection of rows. Okay. Okay, so you can see in the second point where Ram 55 12.3, Sally 52 11.2, these are the two rows containing three columns each. So this is how you generally represent bag in the curly brackets, and the tuple is represented as round brackets. And whenever if you want to load a data as tuple, you will have to format your input data in round brackets. If you want your data to be loaded as map, you would have to format it like a hash table, like in square brackets, and so on. So bag is essentially a set of rows, or data set, or maybe part of the table. You can think of it that way. Okay. The most important part about bag is, in case a bag is not fitting into the memory, it is spilled over to the disk, while map or tuple is not. So a bag is, alright, a bag is nothing but a database table. You can think of bag like a database table. What is a bag? It's an unordered collection of rows, or a row is equivalent of a tuple. Alright. So that's what a bag is, that's what a tuple is, and that's what a map is. Alright. Now the schemas, Pig is not very particular about schema. In case of SQL, when you're loading data, you have to upfront create columns. So Tarak, a tuple is a row and bag is a collection of rows, right? Yes, tuple is one row. Yes. So multiple tuples form a bag. Perfect. All right. Everybody clear about this? Yes, the curly ones. All right. Now, so here the bag contains unordered collection of tuple, and tuple contains values. Each value of a tuple can be either the simple type or complex type. Right now we have only demonstrated with simple type such as string and integer and the float, but they could be further nested. So yes, bag could have multiple maps as well. Multiple maps will not be in this form. Bag will always have only tuples as part of the collection. Okay, and basically the elements of a bag are tuples. Okay, so if you have to define something as a map or something, you will have to create a field here that can be a map further. So you can have things like as complex as this. You can have something of this sort, or so this is one row, this is another row. Okay, and in case, let's say you could have, not here, you could have a hash 1 and b hash 2, something of that sort. You can have as part of the bag. Okay, make sense to you? So what part did you not understand, Nitika? Which part do you want me to repeat? So Tarak's question is, so in this case, bag has multiple tuples and each tuple has map in it. Correct. So here what is it? This is basically a big bag containing two tuples. These are two tuples and each tuple contains four fields. First field is a string, second field is an integer, third field is a float, and fourth field is a hash table, or fourth field is a map. Okay, so these are the three complex data types available with the pig. All right, Shweta. So these are map, tuple, and bag. Of course, yes, they can be nested. Except for here, the key cannot have the anything other than the char array. Yes, we will take up more example. A bag can contain another bag. Correct. So bag cannot contain another bag directly. Bag can contain the tuples which can contain another bag. Okay. So this is a tuple containing, so here you could have another bag, okay, containing something of this sort. Okay. So this is another bag inside the bag. All right. Now we will see more example of this as we go ahead. Okay. So Tarek's further question is, each row, does it need to have identical data type? Not necessarily. Pig is not very particular about it. Okay. So you could have another, like this, where there may not be, the last field. Okay. Or maybe here it's something else. Okay. So when you try to execute your queries, but Pig is not very particular about this. It only gives you error when you try to do something which cannot be done. Say, for example, you are trying to compute the average of these three values. Okay, the third column. In those cases, Pig will give you an error saying that this value could not be casted into a number. All right. Okay, so that's what we are about to talk. So Pig is not very particular about schema. The way we loaded our data here, we only told we only told that these are the name of the columns. While loading this data from this file, these are the name of the columns, and 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 each column you can further you can so in our example we did not define the data type. You could have defined the data type like this. Okay, you could have defined the data type like this. So we have string, again string, and then we could have float. So it's not very particular. Either you could define the data type or you could completely skip it. Okay, or you can partly define the data type. And Pig will do lots of guessing work in figuring out the data type of each field. Partly defined means, for exchange, for example, you may not define the data type, while for symbol, date, and dividend, you can define the data type. That is what partially means. All right. Now here, similarly, while saying that my particular field is same, we can say our particular field is just give it a name without define the data type, or we could go further and say my data type is a map. Okay, the field A has got data type called map. Now we could go one step further. We could also say A is a data type of map where the value is a tuple. Value is a tuple. Key anyway has to be a string. Value is a tuple, and the tuple is, further, the definition of tuple we could give in detail or we could skip. Okay. Similarly, while defining that our particular data type of the field is a tuple, we could also say give the name to the fields of the tuple, or we could go one step further and say that this is the data type of each of the tuple. Same is the case with the bag. And also, if you want to specify data type later while processing the data, you can do that by the way of casting. You can say that convert my data type from string to the number, or from boolean, from a string to the boolean. If you have only true false listed in a particular column, you can convert that field into integer or a boolean. Okay. So just like in Java, we can affix a data type and we can cast it. Here also we can do the same thing. Okay. Yeah. All right. So let's have a break then. I forgot completely. So we'll have a 5 minutes quick break. All right, so let's start. So is everybody back? Should we start? So after 1 hour, if you want to take a break, let me know, and we can take a break at say 10:30 or 10:40. We can take a quick break. All right, so let's start now. So we talked about the data types in pig, and also we talked about the the fact that pig is not too specific about asking about each data type. Just like in if you have used not strictly typed language, just like JavaScript or Python, in those cases you don't have to define the type all the time. It infers the data type. Okay. Similar is the difference between SQL and pig, where in SQL you have to define the data type of each and every column upfront. Now, the first syntax in pig is load. Load is the point where we create the first data set. So we can say divs equals load and we give the file name. So this file name has to be there in the HDFS. Okay, it would not it would not access the local file. Just like in MapReduce, when we say run my MapReduce on this input folder, and that input folder has to be in HDFS. Similarly here also. Yeah. Oh, sorry, Tarak, I missed to answer your question. Okay. So question is, in case we have huge amount of rows and each row has a complex data type, one inside the other, will time be an overhead? Okay. So it would not, ideally, when you look at the way it works, is it has to anyway iterate over each row. Okay. Whenever you are dealing with a lot of data, so that there will be a minor overhead. It will not be too much of an overhead, but there will definitely be an overhead. Okay. So unlike the difference between unindexed table and index table, the difference is huge, right? That kind of difference will not be there, but a difference of 2x, meaning if you have a simple table and if you have a complex table, a difference of 2x might be there, or maybe 1.5x might be there, but not more than that. All right. So here this file has to be in HDFS. Okay. So here what will pig do if you just say div my variable equals load file name? What will it do? It will load this file, will try to guess what is the data type, and also it will, by default, it will consider the input fields to be separated by tab. Okay, the input fields, it will take the input field separator as tab by default, and the this location of the file could be relative to the home folder, or could be absolute starting with a slash. All right. In case your input data is comma separated, you could say load nyse, this load my file using pig storage and comma. That means it will consider the input data to be comma separated rather than tab separated. correct? In our example of dividend, our data was by default tab separated. Okay, so here in case you have multiple folders with the name or multiple files with the some name, then you can use this kind of a syntax. So it basically supports the wildcard characters. Okay, so Tarak's question is, for tab separated, is it tab space or a character as a value separator? So it will be slash t basically. Okay, yeah, it will take all the files starting with nysc underscore div. All right. Now, say your data is lying in HBase or at some other place. In case of HBase, let's say your data is in a particular table. You want to load it from there. Okay. So you can say load load this particular table or nysc underscore dividend using HBase storage. In those cases, Pig will try to find in HBase a table with the name called nysc underscore dividend. So you can load the data from HBase as well, not only from the HDFS. Okay, HBase is sort of a database you can think of right now. We will talk about HBase later on. All right. Now, while loading the data, you could also specify exact data type of each value like this. You can see here, you can specify the column name and their data types. All right. So you can define the data type upfront like this. We are telling that name is a character array, ticker is a character array. Character array means the string. And date, we are not defining any data type for this column, while value is float. Next is that you can also load JSON using load syntax in this manner. You can say load my JSON file. JSON file is JavaScript object notation and is a complex object in itself. Okay, JSON file on the top level contains key value pairs and value can be further another object and so on. Okay, so JSON file is fairly complex in that. So all right, before I move on to that, let me clarify, Nitika. The date is there is no data type right now for the date, or maybe I have not seen it so far. Okay, so date is not a data type right now. All right. But anyway, let me have a look at in case they have introduced in the most recent versions. All right. So if your data is lying in JSON, you can load it using this kind of a syntax. Okay. You can say that load my JSON file using JSON loader. Okay. And how? The food is a character array, the person is a character array, amount is an int. So basically it will try to create three column data set based on the JSON folder. Yeah. So here, if you have a CSV file, you will use this kind of a syntax. You will use this kind of a syntax. All right. Now, once you have loaded the data, you can do multiple things with the data. So your data gets loaded into divs. Now you can do multiple things with divs. The initial most simplistic thing is you can say explain my data set. Okay, or you can say describe my data set. Explain will tell you exactly what is going to do, what is it going to do with when you execute it, when you dump a data set, what is it going to do internally? Is it going to execute MapReduce, or is it going to read the HDFS file directly, and so on? So explain shows you the detailed plan with respect to the query. Now describe data basically just tells you the field name and their data types in this data set. All right. Okay. Now, Nitika, what was the question? Anything or something else we want to use? Was it with respect to the JSON one? Yeah, correct. So anything, it could be column or colon or something, or in case of correct. You are right that we could use in case your data is colon separated, you could use that character. All right. Now next is that also there are multiple tools which give you syntax highlighting of Pig Latin syntax. You can use them. And after loading, if you want to see what's inside the data, you can simply say dump, or you can store. Okay. Given a data set, you can basically either dump or the store. Store stores the data file into HDFS or into any other storage. If you want to store your data comma separated, you can use using pig storage and mention comma over there. Or in case you want to store things separated by double single colon, you could use pig storage and colon to store the data using double colon. Sorry, single colon, not double colon. All right. The other similar is dump. Dump is generally used like as if you are printing something, and it's useful for debugging.